Hello everyone, today we will be considering another problem on IVP. The question says we should find out the third approximation of the solution of this IVP, that is initial value problem. The derivative of y with respect to x is equal to 2 minus y over x, shows that y of 1 is equal to 2. By being given this problem, we all know that our yn of this approximation solution is given as yn y naught plus from s naught to x f of x yn minus 1 ds. We all know that this is the formula for the successful approximation. So how can we now solve this initial value problem of this derivative of y with respect to x? Remember that we have an initial condition which stated as y s naught is equal to what? Y naught. And we are being given the initial condition here. That is, our s naught is 1, then our y naught is what? 2. We just substitute when s naught, we are going to put 1. When y naught is this, we are going to put 2 into this. Then we will now find the third approximation of the solution. That is when n is 1 to when n is 3. So let us start at putting n is 1. Putting n is 1. If you put n is 1 into this n of s approximation solution, we are going to have y1 is equal to y naught. What's our y naught already? Remember that whenever we have y naught here, we have y where n is 1 here. Here will be what? Y0. So we are going to have from s naught to x f of x y1 minus 1 ds. So from here I can have what? I have our y1 is what? y1. What's my y naught? My y naught is y naught plus from s naught to x f of x y 1 minus 1, that is 0. Remember from here, we have been given our f of xy. So our f of xy is this. So our f of xy is this. F of sy is what? 2 minus y of x. So we now have f of what? Xy naught. It means whenever we see y, we are going to replace that what? Y naught. So we are going to have y1 is equal to, what's our y naught already? Our y naught already is what? 2. Y naught is 2. S naught is 1. Then our y naught is 2. This one give us this. Then what do you have next? Plus from s naught to x, our s naught is 1. F of xy naught. So our f of xy is what? 2 minus y over x. But we have y as what? Y naught. I'm going to have y naught. Then ds. So what is my y naught? My y naught already is y1 is equal to 2 plus 1 from 1 to x 2 minus y naught. What is my y naught here? My y naught already is what? 2. That is 2 all over x ds. So what are we going to do here? To integrate the integral part. Then we're going to have our y1 as what? 2 plus, what's my, from 1 to x. If I integrate the integral part, what am I going to have? I'm going to have, if I integrate 2, I'm going to have what? 2x. If I integrate 2 minus x, I'm going to have 2 ln x. That is, if I have 1 all over x, then 2. So if we integrate 1 over x, we all know the loss of this 1 over x, I'm going to have what? Ln s. But if I differentiate ln s, I'm going to have what? 1 over x. So it means if I integrate 1 over x, I'm going to have what? Ln s. So we have 2 here. That is 2 ln s plus c. But here is not a what? But here is what? It's an indefinite integral where we have our upper band and lower band. So we're not going to have c. I'm going to have 2 ln s from what? From 1 to x. So for me, I'm going to have 2 plus 2x minus, so if I integrate 2 over x, I have what? Minus 2 ln x. Here we have from what? From 1 to x. If you put when s is x, we are going to get this back. If you put when s is 1, we are going to have 2 minus 2 minus 2 ln x. What is our x? X is 1. We know that I'm going to have 2 plus 2x minus 2 ln x minus what? Minus 2 minus 2 ln 1. So ln 1 is 0 minus 0. So since I've taken this, I don't have to write it up here. So what did I have again? So I'm going to have 2 plus 2x minus, so these two we call these two. So I'm going to have my y1 will now be 2x minus 2 ln x. So it means I've gotten my y1. So let us consider the second approximation at n is equal to 2. At n is equal to 2. So I'm going to have y2 is equal to, I'm using this as well. This is our yn of successful approximation. So if our n is 2, here will be 2 minus 1, 1. So I'm going to have y1. So I'm going to have y2, y naught plus from x naught to x, f of x, y1. Remember, if I have y2 here will be y1. If I have y3, the next here will be what? Y2. So it means if this one increase, this one will be decreased by what? 1. Then ds. So I'm going to have my y2 is equal to, what's my y naught already is 2 plus from x naught is 1, from 1 to x, f of x y1. So this is our f of xy. So it means whenever we see y, we put what? Y1. I'm going to have 2 minus y1 of x. 2 minus y1 of x, then ds. So what am I going to have next? I'm going to have y2 is equal to y naught is what? 2 plus, if I integrate, what's our y1 already? Y1 already is 2x minus 2 ln x. I will just input it. Whenever I see y1, I put what? 2x minus 2 ln x. I'm going to have from 1 to x, 2 minus 2x minus 2 ln x all over x ds. So from here, so I'm not going to integrate. So from here, I can have y2 is equal to 2 plus from 1 to x. If I integrate 2, I'm going to have what? 2x minus this 2x all over x. If I have 2x all over x, but from here, this minus, this negative is affecting y1 of x. So it means here I'm going to have 2x minus 2x plus 2 ln x. This minus is affecting all value of y1. So this minus is affecting all this. So it means minus 2x plus 2 ln x all over x, all over x, all over x ds. Because this negative, it affects all value of y1 of x. So my y2 will now be 2 plus from 1 to x. If I integrate, I've, I've cleaned the x since I have integral sign here. If I integrate 2, I'm going to have 2x. So I don't need to write integral again. So I'm going to have 2x minus. If I integrate 2x over this will cancel this. Yes, I'm going to have minus 2. If I integrate minus 2, I'm going to have minus 2x. So this minus 2x cancel minus 2x is 0. So what if I integrate 2 ln x all over s? So if I integrate 2 ln x all over s, what am I going to get? Let's integrate it together. I have 2 ln x all over x ds. But if I integrate this, what am I going to have? Let's use a substitution method to integrate this. Let u should be ln x. If I integrate ln x, if I differentiate ln x with respect to s, that if I differentiate u with respect to s, I'm going to have d over ds what? 1 over x. So what do we have here? What do I have here? I have 2. So I can take 2 outside. If I take 2 outside, what am I going to have? I'm going to have, I have ds here and 2. So let us solve the ds. What do I have here is what? I want to replace ln s. I've gotten ln s here. I want to replace that u. So ds, I want to make a value. I don't want ds to be here again. So I want to let it to represent another one. That is substitution. So I can multiply throughout by ds. If I multiply this one throughout by ds, I'm going to have ds. So ds will cancel this. I'm going to have du all over what? 1 over s ds. The reason why I do this is that I want to find another value to replace dx. So I want to find another value to replace ln x. We know that I've integrated ln x as what? 1 over x. That is our use what? Ln x. So from here, I'm going to have 2 outside because 2 is a constant. So ln s is what? U already. Then what is my ds? My ds is what? 1 over s ds. Then it replaces the what? Du. So it means 2 ln x all over s ds. I break it down. I got what? Integral u du and 2 is outside. So for me, I can now integrate this one with respect to u. If I integrate u, I'm going to have u1 plus 1 all over 2. Then plus c as a constant. So 2 is outside here. 2 will multiply this. I'm going to have 2u2 all over 2 plus c. But here, what do we have as u? This is what? Ln s. So I'm going to have 2 ln s square all over 2 plus c. Since it's an integral, so that is 2 ln s square all over 2 plus c. So if I integrate 2 ln s square, 2 ln s over s, I'm going to have 2 ln s square over 2. But here is what? 2 will cancel 2 here. So I'm going to have ln s square. So it means if I integrate this, I'm going to have ln s square plus c. So I'm going to have ln s square plus c. So this is how. So it means if I integrate 2 ln s all over s, I'm going to have what? Ln s square plus 6. But this is a what? Definite integral from 1 to x. That is plus what? Plus ln s square. So from here, from 1 to x, you can make a screenshot of this. I don't need all these things. I just show how we got 2 ln s all over s. So if you know that, since you know that if you integrate 2 ln s all over s, you're going to have this. You just write this as ln s square plus 6. This step shows how we got ln s square plus 6. I cannot just write ln s square plus 6, ln s square. So it means if I integrate 2 ln s all over s, indefinite integral, I'm going to have ln s square plus c. But here's the word definite integral having an upper and back, so ln s square. You can make a screenshot for this. So what am I going to have next? I'm going to have 2 plus 2x. When s is x, I'm going to have this. So 2s minus 2s is going to cut. So this is going to cut. So I'm going to have ln s square minus what? Ln 1 raised to the power of 2. So ln 1 raised to the power of 2 there is 0. Ln 1 is 0. So I'm going to have y2. Y2 as what? 2 plus ln s square minus 0. So ln minus 0 there is minus 0. So my y2 will now be y2 is 2 plus ln s square. So let us try at n is equal to 3. So I'm going to do so that is our what? Third approximation at n is equal to 3. That is third approximation. Third approximation. So let us try it together. So I'm going to have y3, then y naught. Our y naught already is what? 2 plus from what? 1 to s. Then f of x. So it means I'm going to have this f of xy. F of xy 2. Our f of xy 2 is now f of xy 2. That is 2 minus what? Y2 of x ds. I'm going to have 2 minus y2 of s ds. But our y2 already is what? Is this 2 plus ln s. That is 2 plus ln s. This minus is affecting all this. Yes. The minus is affecting all this. That is 2 plus what? 2 plus ln s. And we have here over what? All over x. So here I'm going to now have y3 is equal to 2 plus from 1 to x 2 minus 2 plus ln s all over s ds. So this is minus times 2 is 2. Minus times plus is what? Minus. You are going to have minus. That is 2 minus 2 minus 2 minus ln s over s. So if you integrate 2 minus ln s over s, what are we going to have? This ln s square, sorry. Ln s square. We have ln s square. Ln s square. So y3 is equal to 2 plus from integral 1 to x 2 minus 2 all over x minus ln s square all over 2 ds. So all this I'm integrating this with respect to x. So what am I going to have here? I'm going to have y3 is equal to 2 plus. If I integrate 2, I'm going to have 2x minus. If I integrate 2 over x, I'm going to have 2 ln x. Then if I now integrate minus ln s square over 2, what am I going to have? Let's use a substitution method to integrate this. If I have ln s square, I can write it as loss of logarithm ln s dot ln s. Ln s times ln s, I'm going to have this. Ln is common between them. I'll just take s plus s Ln is confused. I will just ln s plus s. I'm going to have ln s squared. So in lots of logarithm, times return to what? Plus. Division return to minus. So I can write this one as plus. That's s ln s plus ln s. I'm going to have 2 ln x. So ln s represents 2 ln x all over 2. I can integrate. We don't have over x, sorry, over x, over x. So what am I going to have now is using substitution method, I will just let u to be ln x. If I differentiate du over ds, I'm going to have 1 over x. So from here, I can multiply this one, du over ds and 1 over x throughout by ds, so that I will be able to get a value that is going to represent ds. So ds will cancel this. I'm going to have du over 1 over s ds. So I will now substitute this back into this. I will substitute this way into, so what do I have here as a constant term? I have 2. What is my ln s? My ln s is what? U multiplied by what? Well, my ds is what? Du. So if I integrate u, I'm going to have u1 plus 1 all over 2 plus c as a constant. There's 2u square all over 2. 2 will cancel this. I'm going to have u square. So what is my u square? My u square is what? Ln s square. So if I integrate this, I'm going to have what? Ln s square. That is minus ln s square. So what am I going to do here? So from here is what? From 1 to x. I will let this one when s is x, when s is 1. So what am I going to have? I'm going to have 2 plus 2x minus 2 ln x minus ln x square minus, when s is 1, I'm going to have 2 minus 2 ln 1 minus ln 1 to the power of 2. So here I'm going to have 2 plus 2x minus 2 ln x minus ln x square minus 2. Ln 1 is 0, this is 0, minus 0 minus 0. So this is 2, this is going to cancel this. So I'm going to have 2x minus 2 ln s minus ln x square. So this is the final answer for the third approximation. It means I have solved the IVP for what? To the what? To the third approximation method. I hope you find this interesting. Don't forget to share to your classmates and others. Thank you for watching.